Hello, everyone. In this video, we're going to continue to look at the slides which we didn't finish last week. Let's pick up from where we stopped. So this is the pie chart that Stephen Few actually thinks actually it works. Stephen Few wrote an article, Save the Pies for Dessert, which is part of the class reading. I like to use this image as one of the few pie charts that actually work. So remember the exercise we did for counting the number of sevens. So we are going to take the same data set and plot this as a pie chart. So here is a pie chart version of those numbers. So at the first look, you might be thinking to yourself, this doesn't look anything like a pie chart, but this will help us to understand the steps and understand the process to start to draw the pie chart and the issues along with the pie chart. So first, there's a moving baseline from one slice to another. So the fives actually do not start until the two stop, and the six do not start until the eight stop. So we can try to make a comparison of the six versus the fourth. So which has more and by how many? So you should be able to find out that it's very difficult to do this because there's no common baseline to make this comparison. In addition, we have to encode with color to tell which one slice that we can actually tell which is the largest from the next. If all the slices in the pie chart were the same color, then we wouldn't be able to tell the difference between slices. In addition to these two issues, which are outlined here, there are the additional issues to interpret angles, arcs, and area, which are the three ways we make visual comparisons in the pie chart. So here, the same data as a bar chart. It's not easy to see that there's one more six than four, and we don't have to use color at all because we have the same common baseline for comparison. So here is an animation to simplify a pie chart. So there are four slices. You can remove the 3D and reduce colors. And then second line, convert into a bar chart. So this will achieve the same purpose with better effects. So look at this pie chart. So this is probably one of the worst pie charts ever. Again, this is from Fox News. They took the opinion poll and decided to visualize multiple responses on a single pie chart. So the biggest issue here is the pie chart adds up to more than 100%. It's actually 193%. There are also some color issues, which we'll talk about later on. So here are some general rules for pie charts. First, do not use pie charts if you have other choices. Second, if you must break rule number one, then make sure it adds up to 100% and make sure there's only a few categories. So start at none and move clockwise from the largest to the smallest values. Make sure you add labels for percentage. Try avoiding 3D effects and keep it simple as much as possible. So here's an alternative to using a pie chart. The top chart shows you a categorical comparison, bananas versus apple versus grapes. It's easy to see and make comparisons. Notice the addition of a target line here. which makes it easy to see the additional information which we didn't have before. So this is now a context to the numbers in the bar chart. Here's actually a good example of a pie chart that actually works. It has an interesting design and might be engaging to the reader for the topic. It's really hard to make comparisons of one cookie slice versus another. So what you can do in this case is have a small bar chart underneath that pie to show each cookie with the data. This will make it easy to see the comparison without giving up the visual design elements that actually quite attractive. So, and this one really wouldn't work as a bar chart. So here's a list of the common chart types. We have already covered many of these. So let's look at the few that we haven't mentioned and we might find useful in the data visualization. So we're also going to compare and contrast to some of these examples for these specific chart types. So this is a real-world example of an energy usage report from Duke Energy. So these three pie charts, three pies, attempt to show energy usage for electricity, gas, and the total energy overall. Each pie chart breaks down the things that are using the energy. Notice how hard it is to make a comparison from one to the other. How about issues with the colors? And what's the story here? It's very difficult to tell the story. So now here's a redesign using a Sankey diagram. This type of chart is really good for showing flow through a system. For instance, in a university setting, how many students come in as freshmen, then change majors each year, drop out, or go on to graduate. So in this case, the Sankey chart starts with the total energy of electricity and gas, and then breaks down into ranked categories of the usage. We can see that 70% of the energy usage is electricity on the left-hand side. But it's not until we see the breakdown on the right-hand side, then we can be clear that heating with gas and heating with electricity are the top two categories. 44% of the total usage is going to heating. So here's another real pie chart that is showing the software package being used by various companies. So it's alphabetically ordered underneath the pie chart, which is not useful at all because there are too many categories. So, well, first we have to go to the table and figure out the G and the T, and then we can read the numbers. So it's difficult to ask questions like what's the top five, what's the second from the top, what's the third. To compare that pie chart to this one, we can easily answer those questions. So here actually notice that the smaller packages are grouped together in the other category. So there are 26 total software vendors here. Adding on other category is one way to actually to aggregate those smaller packages. This will eliminate lots of bars on the bar chart, which may require the reader to scroll and make the comparisons difficult. One only works if information is not needed for those smaller packages. So when readers do not hear all the other smaller categories that we put in the other category. So there's often exceptions to the rules in data visualization, like even for those rules we mentioned before for using pie chart. So even though pie charts are generally thought to be bad practice, it is generally accepted that pie charts on a map can actually work. So this is primarily due to the fact that since the map relies on 2D position for the location on the map, there's no way to have a common baseline. Simply no good solution for visualizing a part-to-whole relationship or even a categorical comparison on the map. So this map was created by the same person who created the Napoleon's campaign, which we mentioned before, who is Charles Maynard. He created this one in 1858 to visualize the supply of meat to Paris in France. So tree map. So here is an example of a tree map. Tree map was invented by Ben Schneiderman. The purpose of tree map is to visualize hierarchical data on a single visualization. So in this example, the tree map shows the world population. So it's colored by continent, and the countries are inside each continent. The tree map reads from the largest in the top left-hand side to the smallest in the bottom right-hand corner. People often point out that it's a rectangular pie chart, but the tree map encodes using data. So we can notice that the country of India has more people than the continent of Africa. So this would be a hard comparison to show with other type of visualization. So tree map can be a powerful visualization, but notice that as the rectangle gets smaller, they don't have labels. So this will require hovering or highlighting as an interactive feature to be useful. Tree map can also be useful for categorical comparisons without hierarchy. In this case, there are 607 companies with 124K campaigns. The tree map allows use to show them all in one view and make relative comparisons. As with the software vendors, we could show the top 10 as a bar chart, which is useful because that represents 70% of the total data. However, the top 10 would not be useful for Fifth Third Bank if they want to know where they rank against the other banks, because they are actually number 19. Using the tree map with interactive features, such as a drop-down box to highlight a certain bank or hover on for a tool tip, can allow for a deeper analysis in this case. So here's another way to show lots of points. So it's actually in a dot plot, or sometimes we call strip plot with jitter. So there's one person who shows the tweets with the word "go" during the World Cup games. He created this chart. During the USA game, the number of characters used to spell "goal" was very slow, topping out at over just 40. But in the Brazil game, we see that someone tweeted out "goal" using almost 140 characters for that single word. This one might be a runner-up as the worst pie chart ever done. In this case, the slices are not even angles of the pie chart, but are sliced in banana shapes across the pie chart. So this chart is supposed to show how often people make online communications, but this doesn't matter much since the pie chart doesn't convey information in any graphical manner that is useful. So let's walk walk through a redesign process on this chart. So if we plot this in Excel, so this will be how it will look like in default with the same type of data. So we can add data labels to make it a bit more useful. But now that we've learned that pie charts are not great for comparison, let's look at some other options. This is a default bar chart in Excel. So we notice the increments of the y-axis by default, and the name on the color legend, series 1, are not very useful. So we can clean this up a little bit and add the data label in Excel. We can even remove the y-axis and the data table in the labels and try to redesign the labels for the bars in a better way. And we can even rotate the chart, which can be very useful when there are longer labels, so we can avoid rotated text. This can make it really easy to read and makes an easy comparison. There may be a different view of the same data. So this is called Pareto chart. So this is often referred to as the Pareto principle or the 80-20 rule. So the chart plots the cumulative percent with each category. So notice that the numbers will not typically come out to exactly 80% and 20% as it did for Pareto, but it can be a very useful chart for determining the course for problem. So in this case, 70% of occurrences are happening every few months or never. So in this tree map of the contents data, we actually say 6 companies out of 607 representing 60% of the total contents. So as an alternative, if the y-axis is synchronized, the line extends from the top of the bar chart. However, notice that the bars are now compressed lower to the x-axis. So this is not actually a problem with this type of data, but it could be an issue when there are a number of low-value bars that would be difficult to compare. So here is an example of sparklines. Sparklines were invented by Edward Tufte. So we may actually call Edward Tufte or Edward Tufte. So they are basically a line chart that has been stripped down to just the line and made it into a small word-sized graphic. So they are not meant to be used as an alternative to a line chart. They were just designed to bring additional context to numbers. So we can place a number of items, number of these kind of sparklines together to see the interactions between them. For example, we can see that after respiration was really high, it was then followed with a really high temperature, followed by glucose. Sparklines can be very useful, especially in a small space. So we can see sparklines on Google Analytics on the left-hand side. And another example is on the right-hand side in the weather app on a smartphone. So it doesn't get much smaller than a phone, other than maybe the Apple Watch. So notice the additional context shown by the sparklines. So we see the temperature is 34 degrees on the right, but the sparkline shows the trend of the temperature for the last 24 hours. So we can now see that it was much warmer early, and it dropped down to 34 degrees. In addition to spark lines, there are other variations. For example, spark bars, spark tweets. So encoded data directly into the tweets. Bill Cleveland created trellis chart, but Edward Tufte broadened this and called them small multiples. So this can be any series of small charts for comparison. So bar chart, or in the case, a series of maps showing the footprint of droughts in the United States by year. On one page, the New York Times visualized over a century of droughts on a single page. So this is the magnified visualization for this small multiples to show droughts footprint in a whole century. The box plot was invented by John Tukey, who is the father of exploratory data analysis. The box in the whisker is used to show a distribution of an entire set of data. This is the strength of the box plot, so which actually can show all of the data. It doesn't matter whether it's 7 million on the planet or 10,000 conference attendees. It would be impossible to show these kind of numbers with dots without significant overlap and a lot of marks. So in the box plot, some major indicators will be displayed. So typically the 25th, 75th percentiles, and the low extreme minimum, maximum, median of the data set. The box plot may not be the easiest thing for the reader to understand. If the visualization is for the general public, then it might be better to avoid the box plot, or at the very least, make sure there's a great how to read this type of chart section. So here is an image shows the relationship between the box plot and the PDF probability density function, which probably you have learned about in your statistics class. So another advantage of the box plot is it uses the pre-attentive attribute of position for the primary comparison. Because of this, the box plot does not need to have an axis that starts at 0. And like the bar chart, it can be rotated vertically or horizontally. So a quick question. Who invented the box and the whisker plot? So here's an example of bullet graph. So a bullet graph, you can see it was invented by Stephen Field. So this actually is similar to other kind of charts. This will encode data using the length of the bar and the position of the target line, which can be extended beyond the current value, so they are not bounded by some upper end. So how to read a bullet graph? So here in this example, the blue bar in this bullet chart represents the actual value, and the black line shows the target for that number. It's easy to see exactly where the actual value is compared to the target value. The shaded area represent performance bands. So 3 types of shaded areas: the dark gray for bad, the medium gray for satisfactory, and the light gray for good. So we can know immediately that the light gray is good because this is area on the chart where the target line is, but not the target line could also be reversed. Showing lower is better. For example, the target would be set lower for defects or expenses. Bullet charts are native in Tableau. They can also be created in Excel, but not so easy. So there may be some variations on the bullet chart. So you may find that by removing the performance bands, that the bullet chart is easier for readers to immediately understand and interpret. The bullet chart on the top simply shows an actual bar versus a target line, similar to what a thermometer might show. The bottom example is the variation created by Jeff Schaffer, which is a dual-axis bullet chart created in Tableau. So this shows both the percentage and the actual values. A slope graph can be a very useful chart to show the trends between two different time periods. This example shows alcohol consumption for the OECD countries comparing 2000 to 2014. The red color highlights countries that increased their alcohol consumption, and the gray line decreased. So while slope graphs typically show two points in time, this visualization created by Andy Kriebel uses a slope graph to show predicted versus actual wins of NFL football teams, which is also available on Tableau Public. Okay, so that's all the example that I want to talk about. If you have any questions, please let me know.